This is very important result for the real analysis. To show that every neighborhood is an open set. Now what is an open set? E is an open set if every point of E is an interior point. If all the points of E are the interior points, then we say that E is an open set. Right? So I have to show that the neighborhood is an open set. For that, if I consider E to be the neighborhood of any point, let's say it is the neighborhood of the point P, right? Then I need to show that every point belonging to this neighborhood is an interior point, right? And what is an interior point? When the point is an interior point, if its neighborhood is a subset of the neighborhood of P, right? If the neighborhood of Q is a subset of neighborhood of P, or you can also say this to be as E, right? So when all the points of E are the interior points, we say that E is an open set, or the neighborhood is an open set, right? This is what we have to do with the proof. Let's start with the proof. Let X be a metric space, right? And let E be the neighborhood of, let's say, a point P. So I can write this E to be as the neighborhood of P with radius, let's say, R. Now to show that this neighborhood E is an open set, for that I need to show that every point belonging to this E is an interior point. So let's take one more point. Let that point be Q. And I need to show that the neighborhood of Q is a subset of neighborhood of P, or it is a subset of E, right? So let this Q point belongs to the set E, and the set E is a neighborhood of P with radius R. Then the distance between the point P and Q is less than R. Yes? So dpq is the distance between the points P and Q. It is strictly less than R. Okay. I need to create the neighborhood of Q now. For that, let's take the remaining distance to be as h. So what is h? H is the distance R minus distance between the point P and Q. Right? I have to prove that the neighborhood of Q is a subset of the neighborhood of P. For that, I need to show that the neighborhood of Q with this radius h is a subset of neighborhood of P with the radius R. For that, let's take one point from this neighborhood, and I will show that this point belongs to the neighborhood of P. Let x belongs to the neighborhood of Q with radius h. If x belongs to the neighborhood of Q with radius h, then can I say that the distance between the point Q and x, this distance is strictly less than h? The distance between the point Q and x is strictly less than h? Yes, can I write like this? Very fine. So if x belongs to the neighborhood of Q, then the distance between the point Q and x is strictly less than h. Is it okay? Alright. Please mark this as 1. Now since dpx can be written as dpq plus, I have used the result for the inequality. Now just now we have shown that this distance is strictly less than h from the point 1. So writing dpq as it is plus this distance is strictly less than h from 1. And dpq plus h is what? The distance between the point P and Q plus this h. This is complete radius R, right? So this is your R. This is equal to R. So therefore what we are getting? The left hand side dpx is strictly less than R. Please note that I have written R in place of this. I have not changed the sign, right? Make sure of this. Now distance px is strictly less than R with radius R. Yes? Is it okay? Fine? As we have shown that the distance between P and X is strictly less than R, that is strictly less than the radius of this neighborhood of P. So therefore, X belongs to the neighborhood of P with radius R. X belongs to the neighborhood of P with radius R. Yes? Okay. From where I have taken this point X? From the neighborhood of Q with radius H. So this implies the neighborhood of Q with radius H is a subset of neighborhood of P with radius R. So thus, neighborhood of Q is a subset of neighborhood of P. That is, the neighborhood of Q with radius H is a subset of this neighborhood of P. And when the neighborhood of the point is a subset of the set E, then we say that, and when the neighborhood of the point becomes a subset of another neighborhood or the set E, then we say that this point is an interior point of neighborhood of P of radius R, or the interior point of E, because we have taken E to be the neighborhood of P, right? So writing this, therefore, Q is an interior point of neighborhood of P with radius R, but Q was arbitrary. We can take any point from this neighborhood, right? So Q was arbitrary. Arbitrary means we can take any point from this neighborhood and the result will be true, right? But Q was arbitrary, so therefore every point of the neighborhood of P is an interior point of the same. And when all the points are the interior points of the neighborhood, we say that the neighborhood is an open set. So hence, the neighborhood of P having the radius R is an open set. And we can have this result for every neighborhood, right? So we can also say that every neighborhood is an open set. This NBD means neighborhood. Okay? Alright, thank you.